morning. It is a nice, brisk Saturday morning in March, and pouring out just a little bit of flat work today. But in today's video, we're going to talk about concrete testing and why it's important for you. And the start of it is that we've got to pull these cylinders, which we've done. We'll show you that. And these things are going to wind up going to a lab to be tested. We're going to go through that whole process. So it'll be a few days. Our first break on these will be at 7 days. So we're going to show you that and talk about why that's important and why we're doing it and why you should be thinking about doing it yourself. So we're going to rod it 25 times half full. Then we're going to fill it the rest of the way up. More times, and we're only going to the depth that we were a minute ago. Then we're going to just try to flatten it off, clean it up a little bit. We'll wipe these cylinders off in a second and seal them up. Start telling us what you're doing, Matt.
Yeah, so I'm removing the plastic mold from the cylinder so we can label it and put it in the tank. This is it's kind of a newer way to strip the cylinders. As before, you'd have to take one of those hammers and this stripper over here and do it manually, each one. But we've got this stripper here.
This seems like it'd be an easy idea.
Yeah. So we take it, just label the top of the job number, the set number, the date it's going to be tested, and what cylinder ID it is. And then we'll put it in the water storage tank. So we'll do that for every cylinder. Before we test it, we'll prep the end of that. We'll saw it.
So you guys have like a big cutoff saw here.
Yeah, it's in the curing room.
These are the first ones that we've ever pulled, so.
Yeah, you do okay. Probably during transport. If you move to an additional location and maybe get tilt. So otherwise, you just screen them off the top.
I don't think they were screened off perfectly in the first place.
That may have been problem.
It may not be from moving them. It may just be improper from the beginning.
So they were poured on Friday, which is the 22nd. So it will be
7 days.
29.
7 days, 29.
What's a 28 day?
Actually, the 19th.
All right, so let's explain this real quick. So we're going to break one at 7 days. Because why?
It's an indicator of the strength gain. Typically at 7 days, you want anywhere from 66 to 75% strength. With admixtures, that could change quite a bit. Historically, at your 7 day test, it's within 66 to 75% of the 28-day strength.
And that's, so if it was 4,000 PSI that we're getting,
you want to be around 3,000.
25 to 3,000 or something.
You want to be around 3,000 PSI there.
And then the 28 day, why are we doing that?
Because your strength, if you order a 3,000 mix or a 4,000 mix, that is based on the 28-day strength.
And that's where we should actually see that 4,000 or whatever we've got in it.
That's correct.
All right. Yeah. And now what do we do with these?
We're going to put them in the tanks. You want to see the tanks? We'll start with this one here.
We take
yeah,
them
you can
all
go ahead and take. Yeah, you can go ahead and do that. Here's our carrying room. We use carrying tanks. Basically, we've got 4 tanks. Tank 1, 2, 3, and 4. Our tank 4 is a whole tank. Tank 1, for example, April 1 through April 10th. That's according to the break date. We're going to put those in those tanks. So this is going to be 329. So this goes in tank 3.
these actually go in tank.
Those go in there too. Yep. And if you don't want to get wet, I'll toss them in there.
Doesn't matter where you go.
No, you'll get quicker wet. It'll dry. So basically, all these tanks are temperature controlled. We've got these sensors here. They have to be maintained 73 plus or minus 3 degrees. So when we've got an alarm that goes off, if it gets outside those range, we get a notification and then we adjust the temperature.
So it's really quite a process that you're trying to make sure that there's no outside variables or factors that the ready mix company or the contractor can come back and say, oh, you need to do it.
That's right.
And
it's
that's our
pretty
solid
standard, yeah.
that are out of square tops you're going to fix.
That's right.
That's what you're going to do over there? Yeah. Perfect. What are the little squares in there?
Those are cubes, so they can be either mortar, they can be non-strength grout, they can be, non-strength grout or column base plates, they can be grout used for any kind of deep foundations. The molds here.
All right, so these are what you form the little cubes with.
That's right. Yeah. It's a different procedure, different rotting procedure.
Why do that instead of the full-on cylinder?
Aggregate size. So, obviously you couldn't do a full, if you got 3/4 inch
There's
aggregate.
57s in there. They're taking up all the space. It just won't work. So that's something where that you're almost like just straight Portland or something that's in it.
That's right. Yeah, it needs some ink grout. Yeah.
Now we should have a pretty nice flat surface that should fall within the requirements for the testing standard based off of gaps on the surface and levels of the surface. So,
All right, well, let's break this thing, see what happens.
we have our pad caps with Durapads in them, rated to hold this load.
You're just trying to check how close to 4 inches it is that right?
So you want to take your average diameter reading with your calipers, because this right here is going to be used to calculate its actual surface area.
Okay.
So the machine will record how many pounds it's applying, and then by your input of what your average diameter is, it will then calculate your PSI.
So it'll actually tell us the PSI right here instead of you having to go back and do calculations in the computer.
Yeah, our machine it'll populate the load that it applied, and then the PSI automatically calculated. 5723, set 1, dated for today.
Sometimes we also have these guides to help us make sure that everything is
Nice and straight.
That's essentially just a little speed square is all it is.
Yes, yeah, with a purpose-built little notch so it can fit
over that base plate.
Yeah, but you just want to make sure that it is upright, and if it's off, you use a feeler gauge to make sure that you're within tolerances. We will center this up. What is
This
the,
is gonna be no fun at all because you put the blast curtain on the cylinder. we do not need that on there right now.
what is the expected strength for this?
This is 4,000, wasn't it?
4,000?
I think so.
Is applied, we can put it on hold. Inspect to make sure that everything looks centered and looks fine and not at an angle. And continue on with our loading.
So Nathan, what pounds should it get to right there? Because, you know, this is different reading than what the actual PSI concrete is. So what are we looking for?
So if you're doing a 4,000 mix and you have a range of it is 66, I always use rule of thumb right around 70%. So 4,000 for a cylinder that is 4 inches is 50,265 pounds.
Now, is that at the 7-day point? Or?
That would be full strength, or that's just a correlation.
Gotcha.
If
So
you
we
get
should
to
hit
50,000,
40,000 pounds. Is that right?
Yeah, somewhere around there. So we are past 30,000, and it looks like it's probably going to fail here. Not fully. Sometimes you get the top edges to snap. Now it looks like it's probably failed because it's not able to apply the full amount of the load, this gauge being on the low end, and the load rate has significantly dropped. But we'll just make sure that it's not gonna do anymore, because the gauge is going back up. And that is full failure. Remove the cylinder, and then we will record the type of brake that it has based on charts according to ASTM standards, and then record how many pounds it is. Take a look at what it calculated as its PSI for its 7-day strength. It's going back and forth between its calculated PSI and the load rate.
So it's calculating the PSI right now at 25 something.
2513.
Okay.
Yep.
And this is
And
our
that is-
7-day break on a 3,000 PSI mix. So are we within the standard?
You're definitely going on track. So
Because you guys were saying the other day we needed to be between 60 and 70% at 7 days. Is that right?
yeah, it's right around 70%. There's a plus or minus, but I kind of real quick. It's easy to calculate 70%.
66% would be 2,000. So
Yeah.
I know we got above 66.
Yeah, it should be 60.
We're up around 75% or something probably, right?
somewhere around there.
2,000 times 0.7, we should have hit 2,100 at 70%, so we're well above.
Yeah.
So we're well above our spec where we should be at 7 days.
Yeah.
And then at 30-day or 28-day break, we should see 3,000 or 3,000 plus.
If it follows the common trend, that is definitely within the range of where you want a 7-day break to be.
Gotcha.
So it'll still be able to meet strength in 28.
So continues the same trend as most concrete breaks.
Do you all see very much where you get a positive 7-day result, but then you have a 28-day failure, or not?
Not that I'm really aware of.
You don't remember seeing it at all. So I mean, bottom line, what you're saying is if you've got a positive result at 7 days, you're going to pretty much have a positive result at 28 days. Is that right?
Rule of thumb, that's
That's the case.
Yeah.
The big deal is, though, that if we had a 7-day failure, it gives the concrete supplier, what would that be, 14 more days?
Yeah.
21 more days to hope for the best, to hope that it does something it doesn't normally do and trends up and breaks at a higher number. Is that right?
Yeah, it kind of gives you a little heads up of, you know, hey, we could have an issue here.
And then they go into possibly
Pulling cores and then testing those cores.
Yeah, because they don't
for
want to
an
admit
actual
failure.
strain.
I know. Nobody wants to admit fault ever. So for us, part of the purpose of doing this is that we want to, for a lack of better words, keep the concrete supplier honest, that they're actually sending out what they say they're sending out. And part of where this comes from too is that we've had failures, and I don't mean foundation failures. It's usually been, you know, sidewalk failures and stuff, and it's always this back and forth that the concrete supplier wants to blame the people that placed it. The people that placed it want to say, oh no, it was bad concrete. Well, this lets us eliminate that one component from it and say, wasn't bad concrete, or in fact, it was bad concrete. You know, how much of the time, if you had to just guess at a percentage, what percent of the time do you actually see failed cylinders coming in here that didn't meet their spec?
It'd have to be a pretty low percentage. Most of what we do is larger commercial jobs.
Sure.
So their PSI requirements, very rarely will we ever come across anything less than a 4,000 PSI mix.
Right, but I mean as far as like, if you're pulling cylinders, would you say that 90+% of the time they're passing whatever spec they're supposed to be, they're actually getting there, or is it 99% of the time?
It's probably closer to 99% of the time.
So reality is, most of the time, these guys are sending the right stuff out. And I know about some of the big failures that we've had where things got put in wrong supply tanks and stuff like that. But
yeah.
It's usually a major mistake on their end that leads to failure. It's not, they just send out a bad load of concrete. Would that probably be the case?
Somewhat. I come back to one instance where they wind up accidentally putting way too much fly ash.
Yeah, we don't want to get into the details of that.
No,
I know what you're talking about, though.
But it wound up being an issue, and we did wind up taking tours, not going into any further details.
Yeah, and that's what I was talking about. That was kind of a really big mistake, an honest mistake, but you know, mistake no less. And but on the general rule of thumb, they're sending out the right mix,
Yeah.
generally, and that you guys are seeing.
And nowadays they have most companies have digital ticket systems to where whenever they do something, it records as soon as they leave their plant, as soon as they arrive on the job site, when they're done pouring on the job site, as well as all the other information, if they added water, how much. All
Yeah, and
the
that's a
info,
big thing
mix
that-
ID, so
Yeah,
it's all digital.
that and water is something that we're trying to watch a lot more, because you know, they may be sending that right mix out, but yet it arrives on site and the guys haven't put a super P or anything like that in it, that they want to add a bunch of water to it to where that it levels itself. And now, you know, we've killed the strength of it because of what, not because of what the concrete plant did.
Yeah.
It's what the driver let the guys on site do. And so that's one of the things we're really trying to watch with these guys.
That comes down to whenever you take your sample for concrete, you try and make sure that it is.
I want to let them water it up first on me.
Exactly. You try and get a most representative sample
Yeah.
of what they're pouring. You don't want to take it right at the front. You don't want to take it right at the end of the load. You want to try and get close to the middle.
allow them to add any water that they're going to add to it, because if you take it right before they add so many gallons of water to the load and you make your cylinders, then
just a totally
it's not
skewed
gonna,
result.
Yeah, it's not going to represent what they actually place.
Yeah.
So,
Well, Nathan, I appreciate it. I wish it had like exploded and just, you know, been way more interesting, but it is what it is. So thanks a bunch.
They do that though. They will.
Well, that one shattered pretty bad, but you know, your jacket that you put on it just ruined the whole effect.
Oh, sorry about that.
All right. Hey everybody, so thanks for tuning in. Just a little insight into what these guys here at DDS do, but also just what we need to be doing and thinking about as builders. Again, from talking to Nathan in there, it's not so much the ready mix suppliers, but we do have to wind up verifying what we're putting in and doing a better job as builders. So for Building Basics, I'm Jason. Thanks for tuning in.